Our discussion from molarity to molality. We've already discussed the molality, molar mass, and molar volume. So now let's proceed to midterm, another midterm coverage, which is molality. So there is a big differences between molarity and molality. Kasi on molarity, you are actually um, looking for the volume of a substance, while in molality you are looking for the mass. So to explain it further, let's discuss now molality. So first and foremost, define what is molality. The volume of solution changes with the temperature as it expands or contracts, altering the molarity of solution. Or it is sometimes more useful to describe solution in terms of how many moles of solute are dissolved in a specific mass of volumes. That's why I'm saying a while ago that molality is focused on the mass or the weight of a certain solvent or a certain substance. So that is the result as a molality. So the ratio of number of moles of solute dissolved in 1 kilogram to solvent. So meaning to say the concentration of the resulting solution can be expressed in terms of moles of solute per volume, which is molarity, or moles of solute per mass, which is molality. So the differences, the focus for molality is per mass or the weight of the substance, while the molarity is the volume or the molarity is on the moles of solute per volume, while the molality is focusing on the mass of the substance. So to discuss it further, let's specify let's emphasize first the formula. So molarity is equals to moles of solute per liters of solution, which is the abbreviation is big M, while molality is equals to moles of solute per kilogram of solvent, which is the abbreviation or the shorthand M. As it's clear, the molality of solution is calculated by taking the moles of solute and dividing by the kilograms of solvent. So the constant formula or the formula of molality is equals to moles of solute over kilograms of solvent. So that is that is constant, cannot be changed. That would be the formula for molality. So now let's go on the example. We've already prepared some examples for molality. So for example 1, suppose we had 1.00 mole of sucrose, it's about 342 grams, and proceeded to mix it into exactly 1.00 liter of water. It would dissolve and make sugar water. We keep adding water, dissolving and stirring until all the salt was gone. We then made sure everything was well mixed. What would be the molality of the solution? So that would be the question. So here the question, the given would be 1.00 mole and 1.00 liter. So as you can observe, as you can see, that the unit for the second given is liter. So suppose we have to convert now liter into kilogram. So remember that 1 liter is equals to 1 kilogram. So just change it into kilogram. So to specify it further, notice that my 1 liter of water weighs 1000 kilograms, and the density of water is equals to 1.00 gram per ml and 1000 ml of water in liter. So 1000 gram is 1.00 gram. So that was I'm saying a while ago that 1 liter is equivalent to 1 kilogram. So it hindi pa rin siya so the solution, so it will stay remain. So let's just change it into the unit kasi 1 liter is equivalent to 1 kilogram. So here 1.00 liter is equivalent to 1.00 gram. So that makes sense why molality is equals to 1.00 mole, which is given, divided by 1.00 kilogram, coming from the conversion of liter to kilogram. So the answer would be 1.00 mole per kilogram, or shorthand M. You can use mole per kilogram in the unit or the shorthand M. Okay, so that would be the example number 1. Any question? If you have question, you can raise it in our group chat or even in our in my direct message me or PM me if you have question. So next example, suppose you had 2.00 mole of solute dissolved into 1.00 liter again of solvent. What is the molality? Again, molality is equals to 2.00 mole, which is given over from the conversion of 1.00 L converted. Let's convert it into kilograms. So 1 liter is equivalent to 1 kilogram. So it makes sense that the result would be 1.00 kilogram. So 2.00 mole divided by 1.00 kilogram is equals to 2.00 m. So notice that no mention of specific substances mentioned at all. The molarity would be the same. It doesn't matter if it is sucrose, sodium chloride, or any kind of compound. So always go back to the constant, which is 1 mole is anything containing 6.0 times 10 to the power of 23 unit. Okay? So that's it. That is the example for number 2. So here, for example, number 3, what is the molality when 0.75 mole is dissolving in 2.50 liter of solvent? So now, for the molality is equals to 0.75 mole equals to 2.50 kilogram. Kasi as I've said, if you are converting the liter into kilogram, if you have to 2.50 liters to kilogram, the answer would be 2.5. So 2.5 or 2.50 kasi let's go back to the constant that 1 liter is equivalent to what? To 1 kilogram. So that makes sense that the answer would be 250 again for the kilogram. So the answer of 0.75 mole divided by 2.50 kilogram is 0.300 shorthand m. Okay? So that's it. So for instance, what if in the question you can encounter not moles but in grams? So anong gagawin? So now let's change from using moles to grams. This is much more common after all that chemists use balances to weigh things and balances give grams not moles. So yes, that is literally happening in the laboratory in experimenting kasi in experimenting we weigh a certain substances. So, meaning to say, the result would be the grams. So, anong gagawin natin if grams ang sa question? Let's just convert it into moles. So, let's try to this example. Suppose you had 58 grams of sodium chloride and you dissolve it in exactly 2.00 kilogram of pure water, which is the solvent. What will be the molality of the solution? So, there are 2 steps in calculating it. Step 1, convert grams into moles. Step 2, divide moles by kilogram of solvent to get molarity. So in above, how can we convert the moles into the grams into moles? It's just look for the atomic masses of the 2 element in the compound. So we have sodium and chlorine here. So sodium, look for the atomic mass and look for the atomic mass for chlorine. So add it. So the result would be 58 grams per mole. So divide it to the 58 grams which is constant. So 58 grams by 50 divided by 58 grams per mole will result as 1.00 mole. So since you've already get the 1.00 mole, then divide it already. So 1.00 mole by 2 divided by 2.00 kilogram gives the answer which is 0.500 mole per kilogram or 0.500 shorthand m. Okay, again, where do we get the 58 grams per mole here? From the atomic weight or atomic mass of sodium and chlorine. Okay? Always remember that one kasi baka malito kayo, ma'am, saan namin nakukuha yung 58 po. So yung 58 po from the adding or the result of the atomic mass and atomic mass of sodium and atomic mass of chlorine. So atomic mass of chlorine we have 35, right? And atomic mass of sodium we have 22. If we add that one, 35 and 22, we have 58. Right? 35 from 22. Okay? Diba? Okay. So, 22 sa sodium, right? Pero sa iba kasing periodic table, meron siyang decimal. So, let's just round off it into 23. So, 35, kasi 22.9 to be exact ang atomic mass ni sodium here eh. So, 22.9, i-round off natin into 23. So, let's add 35, which is the chlorine. So, 35 plus 23 is equals to 58. Yon, di ba? Madali lang. So, I give you another try. Example. So, here I have two examples. Calculate the molality of 25.0 grams of potassium bromide dissolving in 750.0 milliliters pure water. Here, we encounter milliliters, not a liter. So, 80.0 grams of glucose is dissolved in 1.00 kilogram of water. Calculate the molality. So, now we try. So, the possible answer is this. So, here, we have, the calculation would be, first, diba, convert the gram into mole. So, 25.0 grams, which is given, is divided by into the atomic mass of potassium and bromine. So, the potassium would be, atomic mass of potassium, the atomic mass of potassium would be 39, while the atomic mass of bromine would be 80. So, 80 plus 39 is equals to 119.0 gram per mole. So, let's divide it. So, the answer would be 0.210 mole. So, 0.210 mole will divide into 0.750 kilogram. Bakit? Kasi says 750.0 ml. Let's convert it into kilogram. And the result would be 0.750 kilogram. Kasi 750.0 divided by 1,000 is equals to 0.750 kilogram. So, the answer would be 0.280 M. So that would be the answer for question number 5. And for question number 6 would be 80.0 grams of glucose is dissolved in 1 kilogram of solvent. What is it? Molality, sorry. So now 80.0 gram, which is the given, over the atomic mass of the different element. Here we have carbon, hydrogen, and oxygen. Look for atomic masses niya. Okay, look for atomic mass. So, just get the atomic mass of the carbon, hydrogen, and oxygen. So, the result would be a 180.0 gram per mole. So, 80.0 gram divided by 180.0 gram per mole is equals to 0.444 mole. So, 0.444 mole is divided by 1.00 kilogram, which is a constant given, is equals to 444 m. So, that would be the result. So, again, where does the 180 gram per mole get? It is coming from the atomic mass of the different element in the symbol, in the different element in the compound, which is glucose. Okay, so just divide it to the gram, which is 80.0 grams. So that's, as a result, we have 0.444 mole. So that would be the example 4, 5, and 6. So now I want you to answer the practice problem, which is here, this 3 problem. Okay, so just answer this one, 3 problem. Either you can pass it on my Gmail, or you can pass it in my messenger. Okay, so that is the end of our discussion for the topic molality. Okay, before we will end this discussion, let me emphasize about this 180.0 gram here. Kasi baka malito kayo, ma'am, bakit when we add carbon, hydrogen, and oxygen, iba yung result? Paano? Kasi you have to get first the atomic mass of each element, right? So the carbon would be 12. The hydrogen would be 1, right? And the oxygen would be 16. So you have to multiply it to the subscript. May mga subscript dito like 6, 12, and 6. So 12 times 6 subscript for carbon. So it is 72. From the hydrogen, 1 atomic mass times the subscript, which is 12. So 1 times 12 is equals to 12. Then 0 oxygen is equals to 16 times 6. Okay? 16 for the atomic mass of oxygen times 6 for the subscript. Then that leads to the answer, which is 96, right? So add 72 plus 12 plus 98. So the answer would be 180.0 gram. So binalikan ko lang siya para magkaroon ng emphasizes sa 180 kasi baka malito kayo. Okay? Go back to basic na pag-aralan na to sa molarity. Kapag merong element na ganito na may subscript, you have to multiply it to the atomic mass. Okay. Okay? So, that would be the answer on how can we get 180 gram per mole. So, let's proceed. Let's go back to my assignment to you guys here. 1, 2, 3. You have to answer it, and if you have it in a document, it's okay. So just send it to my Gmail. And if you want to write it in a piece of paper, just picture it and send it into the messenger. So thank you very much for listening today. I hope you watch this video because this is one of the coverage for midterm examination. So God bless everyone and have a safe or nice day. Okay, thank you.